It's July the 23rd, 2020, and welcome to the Water Action Platform. This is the 15th webinar we've held since the pandemic began. This webinar is being held live, and at the end there'll be an opportunity for Q&A. If you want to make a comment or raise a question, please open the chat function by clicking on the purple triangle to the right of your screen. In today's webinar, alongside the usual updates, I'm going to showcase a technology which claims it can dramatically reduce your reactive maintenance costs, and I'll share the top 10 things that you should ever need to know about the microbiology of COVID-19. This platform is dedicated to collaboration and knowledge sharing within the water sector. It is open to all and free at the point of use. It is supported by a broad church of sponsors, and I'm delighted to share with you that we have two new supporters, namely Black & Veatch, the engineering firm, and Idrica, the international arm of Global Omnium. These webinars were launched in March with a specific focus on COVID-19. However, over the last few months, the platform has steadily evolved into something much broader, and we now have 10 subgroups covering everything from SDGs to chemical-free treatment. You may recall that on a previous webinar, I shared information from Black & Veatch's Water Strategic Directions report. So I am particularly pleased that not only are they a sponsor for the platform, but three of their industry experts, James Steyer, Zeynep Erdal and Mark Caney, will now participate in and support the knowledge forums on asset management, non-revenue water and digital. If you also want to be involved in any of these groups, please let me know or visit the Water Action Platform website. Now, rather encouraging, the platform continues to grow in popularity. We now have over 950 members from across 69 countries, with Croatia, Guatemala and Egypt being the latest to join. So now, without further ado, let's jump straight into it. We always like to start with an interesting infographic, and this one shows what risks we might expect over the coming 18 months. Coming in at number one at 12 o'clock mark here on this diagram is the risk of a global recession. Now, I know the details are hard to see here, but I encourage you to look at this graphic when I circulate the slides later. At 3 o'clock, we have the increased risk of cyber attacks now that we all work from home. And surprisingly, I thought, because I would have expected it to be higher, at the 7 o'clock mark is the risk that we'll invest less in climate mitigation strategies. Perhaps most relevant to many people watching this webinar is the risk of renationalisation, which is identified at around the 8 o'clock mark. Now, the obvious follow-on infographic, which I suspect we'd all like to see, is one which lists the opportunities rather than the risks that could come out of the pandemic. And maybe that's something for next time. Now, you will remember, no doubt, this slide from the last webinar. I reported on some recent research which had identified that the virus was present in Italy much earlier than we previously thought. And there was also a similar study reporting similar results from New York. Further data is now coming in which shows that these were not isolated cases. SARS-CoV-2 was in Santa Catalina in Brazil as early as late November 2019. This is 2.5 months before the first COVID case was reported in the area and 2 months before the first case was reported in North America. The paper which reported this earlier than expected appearance also tells us something about the relationship between viral RNA load detected in the sewage and the scale of the outbreak. Lots more work is needed, but it's another important piece of the puzzle that we have to solve if wastewater-based epidemiology, WBE, is to provide an early warning detection system. Now, here is a different research paper, and it is fascinating. Well, perhaps fascinating is the wrong adjective. Terrifying might be just as suitable. Because, as we all know, there's frustration growing across the world with the various lockdown measures that are being imposed. People are tired of them. They want to get back on with their lives. The financial, socioeconomic and political repercussions of continuing a tight lockdown are causing concerns around the world at the highest levels of government. Our assumption to date has been that the isolation of infected individuals is key to curtailing the transmission. However, these researchers, Moghaddis et al., have shown that this is probably not true, or at least it's not the full truth. They evaluated the contribution of pre-symptomatic and asymptomatic transmission and found that the majority of cases could be attributable to silent transmission, i.e. transmission from the combination of pre-symptomatic stage individuals and asymptomatic infections. Now, what does this mean? Well, it means that if all the symptomatic cases, i.e. if all the people we know who are ill, are isolated, a vast outbreak is probably still going to happen. Now, on this graphic, which is taken from their paper, you can see how the impact of self-isolating all the people who are ill, both severe and mild cases, reduces the attack rate fairly significantly, the blue line, when compared with no isolation at all, the yellow line. However, note that if you only isolate the severe cases, the red line, which is what's happening in many countries, the drop in attack rate is much smaller. Now, these researchers went on to quantify the effect of isolating silent infections, the asymptomatic and pre-symptomatic cases, and concluded that if we are to keep a future outbreak below 1% of the population, then over 30% of the silent infections must be identified and isolated. This is new news. It is not what we expected. These results indicate, perhaps more strongly than ever before, that the current symptom-based isolation approach adopted by many countries to control the pandemic has to be supplemented by a rapid tracing and testing regime that identifies the asymptomatic and pre-symptomatic cases. And this, as we've discussed many times previously on these webinars, is exactly where a wastewater-based epidemiology system that can give an early warning of an outbreak has a part to play. We must continue working to make this a reality. Now, I've spoken in the past about some of the great work that certain IFIs, international finance institutions, have been doing. We've shared highlights from the World Bank, the IADB, the EBRD, and the ADB. This week, I want to share something from the IFC. They've produced this report looking at the impact of COVID-19 on water and sanitation. The findings are, on one level, very similar to what we've seen before, namely that the poorest people in society have been served a double whammy of COVID-19 coming on top of their already struggling water and sanitation systems. This IFC report identifies the support that's required, which, not surprisingly, is centered around the provision of finance solutions and encouraging peer-to-peer learning. This report, however, goes on to ask what will be different in the future. And they've identified a number of activities listed here. The one I particularly like is the third bullet point, namely the scaling up of wastewater reuse as a cost-effective solution to water scarcity. This is practiced in many countries already, but not widely enough. If this pandemic encourages more beneficial recycling of wastewater, then perhaps a small glimmer of hope could be drawn from this otherwise bleak situation. Now, here is something that came up from the AI and Digital Knowledge Hub, and it relates to gamification, i.e. the use of game design techniques to enhance non-game contexts. Now, in this study, these techniques were used to encourage more efficient management of water consumption. Basically, it was a study to encourage people to compete to save water. But unlike some of the previous studies where this Smart H2O project went beyond the social comparisons and rebates that are often considered, and they compared visualization and saving tips with various rewards. There was an initial peak of water saving activity, which then settled down to a constant level. After adjusting for seasonal effects, the water savings were around 10%. Pretty good and worth having at the right cost. As we enter into the summer drought months, solutions like this might well prove to be very cost effective. Now, staying with the water usage theme, but returning to the COVID-19, back in May, one of the topics which was a key focus for this forum was the issue of water shutoffs. There was much debate around the undoubted social duty that water utilities have to provide clean water and sanitation services to everyone, but countered by the clear financial implications that come from providing these services for free or at discounted rates during the pandemic. This issue is further complicated by the fact that there are some people who have the ability to pay their water bills, but they use the excuse of the pandemic to avoid doing so. Trickle meters, or meters that provide a restricted flow of water, have been around for many years. It was recently reported that Phoenix Water has tested the use of a flow restrictor to help address the problem during the pandemic. The device is inserted into the service line, restricts the flow into the home or business which is behind on their bills. It is, Phoenix Water state, a softer stick than doing a complete shutoff. It creates an annoyance for the resident, but doesn't create a public health risk. 2 meter manufacturers were tested, Badger and Muller, and the trials appear to have progressed well. If you are facing a similar challenge, then perhaps a similar approach might apply to you. Moving now from water supply to wastewater related challenges, The increase in the use of PPE during the last few months has resulted in many unsuitable items being flushed down the toilet. These are collecting at the head of sewage works and creating all sorts of problems. In Zagreb, Croatia, a public appeal has been made after the central water treatment system became clogged with a large amount of unflushable items, including disinfectant wipes, respiratory masks and silicone gloves. To make matters worse, the workers on site had to clean it by hand, thus exposing themselves to further risks. Now, this isn't a new issue. Many wastewater utilities have intense and effective bin it and flush it campaigns that have been running since long before the pandemic began. But their importance now is greater than ever before. On a similar vein, researchers from the National University of Ireland in Galway found that sediments near a wastewater treatment plant were regularly strewn with microplastic fibres, consistent with those coming from wet wipes and sanitary pads. Here's the diagrammatic version of their research paper, which we always like to share. What they noted was that for a wipe to be considered flushable, they must be comprised of plant-based polymers, which degrade during the wastewater treatment. However, 50% of the wipes that were labelled as flushable were shown to contain plastics. Even worse, at one of the sites that these researchers studied, they found over 6,000 microplastic fibres per kilogram of sediment. Now, I know I'm preaching to the converted here, but we can't afford to let our understandable concern for personal protection during the pandemic allow us to excuse behaviour which will have a long-lasting and devastating effect on the surrounding marine environment. To do so would be a severe dereliction of our responsibility. So to me, it feels like it's time to raise the profile of the Bin It, Don't Flush It campaign. We now come to some good news released earlier this week regarding a potential vaccine. Oxford University has developed a vaccine which, following tests with 1,000 people, shows that it can help those injected create antibodies which will fight the coronavirus. We've seen this particular graphic before. It's produced by the World Health Organization and it shows the number of vaccines being developed currently. You can see there are 3 in phase 3. The next phase of the Oxford Uni trial will involve 10,000 people and it's being expanded to other countries, mainly because the levels of coronavirus in the UK are relatively low, so it makes it hard to be certain it's truly effective. So in addition to the 10,000 in the UK, there's going to be a large trial involving 30,000 people in North America and 2,000 in South Africa and 5,000 in Brazil. There are even calls to perform challenge trials. That's where vaccinated people are deliberately infected with the coronavirus. There are obvious ethical concerns due to the lack of treatment. We will continue to monitor progress on this and the other vaccines and keep you informed. We now come to this week's sector expert, and it's Jo Burgess, based out of South Africa. Dr. Burgess is a biochemist and microbiologist, and she is the leader of the Knowledge Hub group on SARS-CoV-2 in wastewater. Over the past few months, Jo has been my mentor, my guide, making sure that I use the right phraseology and terminology when talking about COVID-19. It's something which I am not sure I have 100% complied with, and so I say here that any errors you might have noticed will have been completely of my own doing. But I recently invited Jo to give us a mini lecture, let's call it a basic 101 on the microbiology of COVID-19. She kindly provided a brilliantly informative 8-minute recording, which is available on our website. She also provided the perfect 3-minute summary of the top 10 things that you need to know about the virus. It's so good that I wanted to share it with you here.
Hi everybody, and welcome to the top 10 things to know about SARS-CoV-2. Number 1. COVID-19 is the name of the disease. The disease is caused by the most recently discovered coronavirus, severe acute respiratory syndrome related coronavirus, SARS-CoV-2. A virion is a complete infective viral particle consisting of the RNA of the virus surrounded by its envelope. Fomites are inanimate objects like doorknobs that can be contaminated with virions and then give them to you. So in this case, the classic example is if somebody sneezes on their hand, uses a handrail, and then you come along behind them and use it afterwards. The coronaviruses are a group of related viruses that cause diseases in mammals and birds. There are about 40 of them, and they are not new. They were discovered in the 1930s in domestic chickens, and the first human coronavirus to emerged in the 1960s. SARS-CoV-2 is the 7th coronavirus to emerge. They're very, very closely related. This is very good. You can see on this phylogenetic tree just how closely related they are. Here are all the SARS-CoVs, and the ones with red text, SARS-CoV-2 and SARS-CoV, are the ones which are able to infect humans, and they share about 78% of nucleotide base pairs. So this means that what we know about SARS-CoV is probably true for SARS-CoV-2 as well. The next thing you need to know about them is that they have absolutely enormous RNA. The reason this is good is because it's very easy to detect. So here's the spike glycoprotein, that's the naughty bit that attaches the virus to your cells. Here's the envelope membrane protein, and here is the membrane protein. The three of them are embedded in the lipid bilayer, this grey circle going around the cell, and this is what makes it so fragile. Soap destroys the lipid bilayer, and that enables us to kill the virus. This blue squiggle is the biggest strand of RNA yet found in a coronavirus. It's about 30 kilobase pairs, and the reason it's so good that it's large is that it makes it very easy to detect. People infected with SARS-CoV-2 shed the virions and pieces of viral RNA from broken virions in their bodily excreta. Whether they have symptoms or not, they shed it, and even if they test negative for COVID-19 with a throat swab, they shed it. People that do have symptoms carry on shedding virus RNA and virus particles themselves for 7 weeks after they recover, if they become ill. All of that stuff goes in wastewater. We flush it down the toilet. So wastewater and receiving bodies have a significant role as potential sources of epidemiological data and also as factors in public health risk. Coronaviruses haven't been waterborne in the past, so the standard virus concentration and detection methods we use for viruses in water don't work very well for enveloped viruses. Because of this gigantic RNA, we're seeing a lot of work coming out now detecting the presence of SARS-CoV-2 RNA in wastewater, but that doesn't mean that there are infected virions in that water.
I've watched that video probably 3 or 4 times. I think it's just brilliant. I suspect it'll be on our website. I suspect that it'll get massive numbers of hits. If you enjoyed it and you like that sort of format, please give us the feedback, because we can do more of that sort of thing if it's helpful. Now, as I mentioned at the beginning, in addition to that lovely 3-minute summary of the top 10 things you need to know, there's also a longer 8-minute lecture available on the website. I love these videos. Sorry, my slides have just gone all confused here. We now come to the technology showcase. And this week's technology showcase is with 8Power. 8Power is an asset condition monitoring company. They have a long background in semiconductors and wireless networks and the like. They are not your typical technology company, water technology company. For the avoidance of doubt, ISLE has no commercial links with 8Power. We identified them through our long-running technology approval group forums, which I won't discuss here. I'm showcasing them today because in a world where remote monitoring is going to be ever more important, they have something quite special to bring to the table. Also, following a study with a UK water company, they claim they can save over 10% of the reactive maintenance budget, which for many water companies puts that saving in the order of millions. 8Power have developed an easy-to-install self-powered sensor that's able to monitor industrial assets such as motors and pumps and provide an early warning of equipment failure. This is a picture of their typical sensor, and it fits easily into the palm of your hand. The really clever thing about 8Power is that their technology is truly fit and forget, because it is powered by vibration energy harvesting, or VEH. What this means is that they use the vibrations from the equipment that they're monitoring to generate the power required to both run the sensors and the wireless communication. This means that their sensor doesn't require a mains electricity connection, a solar panel, or periodic battery changes, as almost every other sensor does. It can operate without an external power source for 10+ years in harsh industrial environments. Here is a 3-minute clip of the 8Power CEO Paul Egan sharing more details.
We think that's going to change how people are going to be doing condition monitoring. So if we look at how battery sensors operate at the moment, there's a choice that you can either have long battery life with not much data, or you can have lots more data, but you have to factor in sending someone to change batteries in a lot of these sensors. And we think this combination of energy harvesting with wireless sensing and cloud analytics is really going to change how we're going to be looking after many of these machines. So we're a startup company. We're a spin out from Cambridge University, which is where the original innovation came from. And we have deployed product with Anglian Water, and we're doing work with ABB as well on this. So we have these attached to motors, pumps, and other industrial things. They generate their own power. From that, we can then send that data via Bluetooth 5 to an on-site gateway. And then the gateway has either mobile connectivity with 4G, or we can use Ethernet or almost any kind of backhaul that you want to there. And then obviously we can then go from there to the cloud. Now, the reason we like this particular architecture is we can generate most of the KPIs and most of the statistics for the analysis of the actual motor itself, actually on the device. So we think that gives you the opportunity that an engineer can actually go up to one of the assets, just use their mobile phone with an app we've got, and actually get most of the condition monitoring data direct to that handset. You don't always need to have the communication to the cloud to enable that. So we think that that's pretty useful. So why is energy harvesting so important? So certainly some of the work we've done with ABB at the moment has convinced us that sensors are only going to get smarter. So being able to run more intelligent algorithms, being able to run them more often, means that they're going to need more power. Now, is everybody in the room familiar with the term Moore's Law? So in 1965, Gordon Moore, who was a founder of Intel, stood up and said, as far as I'm concerned, every 2 years, the amount of processing power we're going to get is going to double, and the cost of that processing power is going to halve. Now, we've lived that through our mobile phone and internet revolution. Unfortunately, there is no Moore's Law for batteries. So batteries are only getting better at about 5% per year. So you can see there's quite a large energy gap there in terms of what you really want. We think that larger, bigger batteries are not the answer to solving this problem. If we look at how much lithium is being mined globally, we know that there's going to be a competition between electric vehicles for the batteries going in there and the kind of batteries going in here as well. So we think that there has to be a change in how we're going to do this. We believe that that's going to be energy harvesting. Now, we really believe that condition monitoring is going to change the way that many of these assets are actually being used. So motors, pumps, conveyors, Archimedes screws, many of the assets you're using all the time, we think there's going to be a change there and a revolution. We think that removing the problem of having to change batteries is going to enable that, and we think that that is going to actually accelerate the adoption of a lot of these kind of technologies. And we think being able to make these things easy to be installed by existing maintenance teams, so it just fits on some of the studs and some of the fittings that are already on some of these assets. We want to try and make this as easy as possible. I mean, I joke about saying we'll sell this for $299 on Amazon. We're not quite getting to that point, but certainly having a very easy to deploy product that gives you the right data to the right people at the right time. That's this whole kind of system message that we're giving you there.
So there you have it. A whole new world of remote monitoring awaits us. Easy to install and operate with no wiring and able to use existing sensor mounting points. What's not to like? Even better, the devices contain 96% less lithium than conventional industrial sensors. If you want more details, either contact myself or Paul Egan directly. And finally, let's close with something a little quirky and unexpected. I can't promise you that the following item will make you any more effective at your job, but it might, just might, make your children, colleagues, neighbors, friends smile when you share it with them. It starts with a question. What have horror movies such as It, Slenderman, and A Quiet Place got in common which relates to COVID-19? And supplementary question. What are zombie movies such as Day of the Dead and World War Z? Why are zombie movies such as Day of the Dead and World War Z even better? The answer, it appears, is that they help you deal with COVID-19. A group of psychologists and behavioral scientists have found that horror fans have exhibited greater resilience during the pandemic. As shown by this graphic, the more scary films you see, the more prepared you are for the COVID-19 pandemic. Even more intriguingly, the researchers found that fans of alien invasion, apocalyptic and zombie films exhibited both greater resilience and greater preparedness. Clearly, those long nights spent getting scared out of their pants whilst watching the latest nightmare-inducing flick serves to provide horror fans with the level of resilience not afforded to those of us who prefer our movies to have happy endings, preferably where the boy gets the girl and they all live happily ever after. The key takeaway from all this, well, reading and watching apocalyptic fiction allows you to practice for the real thing. But, major downside, you will never get to see the lovely Julia Roberts in a zombie movie. Now, with that, I bring this week's webinar to a close. I thank again our partners and sponsors for their kind and continued support. Before we finish, let's have a quick look in the chat box and see if there are any questions. Megan has been sitting nearby monitoring the questions, and I'll ask her to join me now. For those of you who are worried about social distancing, I confirm that Megan and I are in each other's special bubble.
Thank you. Yeah, so we've had a couple of questions and comments. The first one is from Adam that said, you mentioned the IFC are looking to encourage wastewater reuse and that other countries are already doing this. Which countries are doing this and what have they got right or wrong? And also, is this for potable or industrial use?
Excellent. Brilliant. Thank you. Well, the countries doing it, the obvious two to mention are Israel and Singapore. Singapore launched the new water technique. What they've got right, actually, is the branding. There's this fecal aversion that everyone's understandably got about having the too closed loop between wastewater being recycled and getting into the potable supply. That said, lots of other countries, even here in the UK, we've got some indirect potable reuse going on, and I'm happy to share more details as needed. There was a second half to that question, I missed it.
Oh, is this for potable or industrial?
Oh, is it for potable? Well, actually, industrial use is relatively straightforward because as long as you can get to the purity levels, it's just a bit expensive because you usually need super pure water. Domestic potable water is actually easier to achieve, I think. Good.
Yeah. So we've had a comment saying that is there such a thing as flushable PPE? Probably not.
Oh, what a great question. I love that one. Who gave that question?
Matt.
Matt. All right, well, Matt feels like there's an invention there that's needed. Flushable PPE. We'll do a search on that and we'll report back because that feels like that feels like something that we could lead. And I know it's not really COVID related when I talk about the flushables, but it is COVID related because we're seeing such a huge increase in it. So we're going to take that away and we'll do a bit of homework and we'll report back.
Yep. And then just the last one about the zombie movies. Adam commented saying, who's funding this research? I hope it's not my tax dollars.
Who's funding the research for looking at films? I have no idea, but we'll maybe have another quick look at that too, and we'll stick it on the notes. I suspect it's some university professor who's just got a little bit too much money. Brilliant. Thank you, Megan. Thank you for that. Interestingly, when we did this morning's webinar, I got back comments saying that they really liked the interaction with Megan. I couldn't quite work out whether it was just the 25-year-old difference between us and the fact that they'd had enough of me. Anyway, thank you, Megan. And with that, we close this session. The next webinar will be in 2 weeks' time on August the 6th. Megan will circulate the calendar invites shortly. Keep asking questions, keep sharing, and keep safe. Thank you.